Hello. Get stuff ready. Mm. Uh, so we just to recap, because I keep on forgetting to turn my back on the video. Just quickly recap what the feedback I got for the from the survey was, and we're talking about putting two and two together, the final projects and how they relate to this. People were freaking out about D3. Yeah, there was the I'm required based on the course outline, and we could question that. I'm required based on the course outline to teach something about D3, which suggests that I have to have some kind of measurable deliverable based on D3, which is why we have a lab on it, which is why we have homework on it, uh, but also why the lab and the homework are meant to be, here you go, here's almost the answer. And yeah, you can get caught in it. But I've had a course where we taught D3 and it's nasty. It's really, you can get really lost in that thing because it's JavaScript, and JavaScript, anything that goes wrong, everything goes wrong afterwards. So D3 seems to be mandated for us to do, and I'm recovering it, but I don't want, that's not the emphasis of the course, because if it's the emphasis of the course, it's a very different course. We're not, and if anyone was wondering, I think somebody said, I didn't think it was a programming course. I'm like, it's right there. It's talking about D3 and JavaScript in the course description. So there's programming aspects to this course. That was something that was also not hideable. Um, what we're talking about here is, so that was again an aside. When we're talking about filtering and aggregation, these are not always, sort of ideal, but this is a nice way of doing it. Notice if I start typing in something like 0 to 1, it sequentially filters every time I put in a new number, versus me typing in my zip code, if you're an American, and typing your zip code and seeing that one little tiny part. You wouldn't get, if you don't have this interactive part of it, you don't get to see how sequential, how the zip codes in the United States actually work. There's another, or that if you got it right, or how off you are, right? So if I 0 to 1 7 7. Oh, 7 7 is also a Melrose thing. Okay, 7 8. No, Belmont. 6 6. Okay, let's say I put 02166. Wrong zip code. Not the zip code that I was looking for, but I don't know which number's off. Let's say I'm looking for Melrose, Massachusetts. I can't remember because it's been a couple of years. So I put 02166 and I get Auburndale. Now, if I have it like you type in this full thing and then you press submit, and then you will get your results, you're not going to be able to figure out what you did wrong. There are better examples of this, but this is just one example. By selectively filtering, by filtering as a dynamic query, by changing it as I type, as I do things, changing the results, I can reason about my code. I can reason about how things are working, or make more informed decisions. If I'm changing if I'm, let's say I'm doing the age of your house, and I start selecting the range of my house ages, let's say, to show on the kilojoules used in Canada. If all of a sudden everything, as soon as I start sliding it, I start seeing the change in the kilojoule usage pattern across Canada in real time. I'm not expecting that, but let's say I did that. I can make big conclusions about, is there an actual little step function where beyond a certain point, like 60, we gotta go from 30 years of age to 29 years of age, and suddenly the amount of energy usage drops. Then I go, whoa, there's something happened 30 years ago in terms of energy usage and efficiencies. And previous to that, they're not grandfathered in, or that they were grandfathered in, so you didn't have to make those energy savings. And it makes a huge difference in energy usage impact. Whatever the case is, by dynamically checking out this information, it gives me sort of it allows me to play with the data more. It's more playful versus ballistic, right? It's not this big thing where it goes up, a ballistic meaning going up and down, no control over it at the time. If I'm able to adjust it on the fly, so, and I'm going to get distracted here too easily. I was thinking the sport of curling, right? If I just throw the rock down the ice, fine. I don't have any control. I let it go and it goes down the ice and it does weird things, right? I have no control over how it goes. That's a ballistic act. It's well, really, but just I don't have control over it. The sport of curling is you can adjust the rock as it's sliding down the ice by sweeping in front of it, make it like smoothing the ice by melting the ice just enough to make the rock turn and move and change. That's the sport of curling. I'm talking about that. So by doing little micro adjustments, we can actually get a better, more accurate view of the data. Okay, so I want to just get back to this thing here. This is a dynamic query. It allows me to micro adjust my how I'm looking at things and get a better sense of things. I'm also filtering items. I'm not filtering attributes. That's the third thing that we're looking at. I'm filtering items, the things that I'm viewing, the items that I'm viewing. So it might be the red lights in Ottawa. I can filter out half of them based on the ward, or a chunk of them based on the ward. Give me all the red lights in Alta Vista. I only see the red lights in Alta Vista. Filtering attributes would be each of those red light icons might encode multiple pieces of information. Or maybe it's the outdoor activities group where we have an image or an icon for what goes on, like where the various rinks are. Maybe I want to have the hours of operation and the what kind of rink it is, and if it has a change room and a bunch of other attributes at a time per glyph, per thing on the map. Well, filtering out attributes would be I remove some of those attributes, some of the data that I'm showing per glyph, especially if I'm zoomed out. I don't want all the information at once. I want to keep it simple. And when I zoom in, maybe I get more details. All right. Similarly, here would be, this is not always working. It's a bit, mm, there's some bugs in the code here, but you can interactively filter out the different kinds of health code violations in Manhattan, actually all of New York, but the New York area. And you can filter by attributes. You can also filter by individual items. So you could say which ones had rat violations, honest to God, and based on the cuisine and what other attributes I'm showing. This can show you, for example, I have the different attributes, what color it is, but I could just color all the boats the same way. I can also remove certain boats, so I can filter out the items, removing boats, or filter out the attributes, removing maybe color or removing certain attributes associated with that individual item. Similarly here, a Google map, I can remove, and this is why I was a little surprised by the women, working women on the go group. Right, it's hard to do, but at the same time, you could actually encode the roads themselves with information about the traffic flow. One of the options. Google's already doing it. It might be very difficult to do. So here is smooth flowing traffic. Notice the big green lines. When I hit problems, it goes red. So the amount of traffic flow or the amount of cars on any given area, width of a line, the color indicates the level of traffic, amount of traffic flow. And I can remove certain layers. I can remove certain filters. I can change what's visible on the screen. I might remove the pizza places and all the other places that I may not want to visit at any time. Or I think this is me doing a search in downtown for downtown Melrose and pizza because we couldn't find a pizza place in downtown Melrose. So here are the pizza places in downtown Melrose, where they're located, and there's not a lot that I'm filtering by item, not by attribute in this case. Okay. And here's my live traffic, by the way. So I have an attribute that I can turn off and on, removing an attribute of the roads themselves. That's an attribute filter. Okay. all this to say, haha, we're going to be, here's my outline, then I'm going to hit one other thing. So we're going to talk about filtering and aggregation more. If we have time, hopefully we'll have time, we're going to be looking at networks and node link diagrams, which will give you an advantage for any of you that have not done 2400 yet. You'll get an advantage on that course. We're going to look at some videos along the way because I like this lecture because I get to show last week tonight video. We're going to do a quick review of what we've done. We're going to do a fair number, at least 2 in-class exercises, and I don't know where we're going to go. So let's see how far we can get. But first of all, let's take your turn. I would like, ideally 2, but the second one's the big one for me. I'd like you to go to lecture 13, the lecture 13 drive folder, the first one, the one that just says lecture 13, filtering and aggregation. And I want you to find your favorite dynamic query system. Just pick the URL, maybe get a screenshot of it. And I would like you to find your least favorite, the kind of querying system, the kind of filtering system that has driven you nuts in the past. Just, it is infuriating, it's agitating, it just makes you want to stab somebody, whatever the case is. Okay, what kind of filtering does it do? Ideally, if you have the time, put down, what does it filter attributes? Does it filter items? Does it filter both? How quick is the response? How is it dynamic? Is it not? When you do an actual search, what does it filter? And so ideally what I want is 2 systems, ideally in discussion, but the big one is just give me the worst is the important one. Maybe a screenshot and the URL so we can actually look at it. What I'm going to do afterwards is I'm going to see what you guys submit, and then we can discuss some of these systems. Invariably, you have something, if you just take a second to think about it, you have something, some kind of querying, some kind of filtering system that has driven you batty in the past. Let's have an image of it and let's have a URL seeing what it looks like. I've had some great examples of this. That's why I know that people can find these. Okay, so what I want you to do is find some way of some kind of filtering aggregation system, filtering or aggregation system, like looking for items on Amazon. That's kind of filtering. Or maybe looking for a hotel room or looking for an a flight. It's a kind of filtering and aggregation system. Whatever floats your boat. But the worst one, the one that drove you the most nuts, is the one I'm looking for. All right, I'm going to mute and then I'm going to see what you guys come up with. Ask questions if you're confused by this. I just want to see what kind of examples you've come across in the past. That's the Google Drive link in case anyone needs it quickly. in case anyone's wondering what that look on my face is, Steven's already given a fantastic example so far, but I want to see other people's examples. Unless that's, yeah, it can't be. Anyways, so well, whenever you get your examples, I want to see a couple of them. I want to pick on people that I have not been picking on before. You can type in your chat what you think of it afterwards, but uh, we'll go from there. But right now, just find your least favorite or most favorite thing, and I want to get that same kind of reaction from all of you. I'm going to give about another 2 minutes. I do actually want to see people. I noticed that people were submitting immediately after I talked about it in class. I don't want to be doing that again this time. So what I might do is make sure that you submit it and then turn off edit access once people say that they've done submitting. So please pass in your things in about 1 to 2 minutes. Right now we have the usual suspects that have submitted, so please submit whatever you have. Otherwise, I might just come back to it later. But the way the three that are up there right now look fantastic. Although Madison, I would love to find out what I can do this one. Maybe you can walk me through. Oh, I can actually look at it.
So I actually found this on another, a screenshot of this original query on another website, and then a link that took me to the original author, who was then explaining how bad the system is. And I thought the first visualization was bad, and then as you go through the website, it just gets consistently more meta, and it's very difficult to. Yeah.
But there's no like this is just the design diagram, right?
Yes, for the system that uploads databases to the cloud.
Okay. And then we have, besides that, is this any, like, can you you're filtering based off of this, or is there filtering at all, or is this just talking about databases and how to upload it? I'm wondering where the filtering is in this, that's all. Or did you miss that point?
No, sorry, it's in a visualization at the bottom of the page. Okay. 1 moment.
This thing here, or down here?
Yes, that's what I assumed it to be, the filtering. Yes, as you go through that one, and then there's a more detailed one as you go down. And I assumed those to be how you would filter the data through.
Okay. Oh. I don't even know where to think. I don't think I have the brain power for this right now, this time in the morning. Cluster tables, materialized views, only bulk data loading. Okay. Okay. Automatic scaling. Okay. So there's nothing dynamic about this. This is a bulk process with a bulk filter where it's clunky as hell, right?
Yes.
Got it. Yeah. When you write a diatribe or a treatise about how terrible a bulk processing thing is, you know it's stinky. Nice. I'll have to look into that more. All right. So let's see what other things people found. Well, let's see if I have one more at least. Beatrice. Okay. Lee. All right. Oh, nice. What? You want to walk me through this one? Because that is, I'm not sure if that's my favorite though. That is a weird thing. So how do you filter on these? I don't know. That still depends on the categories, favorite, filter. Okay. So can you walk me through what the heck this thing? Okay, you don't have time to explain. That's the whole point of these exercises, not just throw something up there. You got to be able to walk us through this. How about this? Go back afterwards and fix and fill in what you want for your explanation on this thing. And if anyone doesn't want to talk about their thing, that's fine. We'll go through that as well. Because I don't know what the heck this is supposed to be showing me. It does look kind of crazy, but I get a pointillism task. And I don't know if I can just click on the image or text, video, or site. The URL would be really useful actually. But this thing, anything with a pseudo 3D is gonna, well, it sets me off. It's a knee-jerk reaction on my part. But the fact of the matter is, I don't know what they are teasing out individual threads, but I have no idea how to read or interpret or how to filter any of these things unless I select this and it filters out everything that's in category 6. I have no idea how to read that. It probably is great, but I have no idea how to read that. All right. Okay. That's by a weird way I find confusing first image. Okay. Great. They're at Stanford. Oh, brains white matter pathways. Okay, they're pathway systems. I would have to look into the actual thing. Okay. I'm gonna put that in my list of things to watch afterwards. Oh, damn. There you go. So in case you're wondering, so we're looking at white matter pathways in the brain. So this neuron would be firing all the way down. You'll get actually pathways in your brain, not just single neurons, but they'll go in a sequence. And being able to tease those out tell you different sections of the brain. Now, how efficient that is for annotate or for analyzing this, Rich Mackenzie's involved though. So they know what they're doing, presumably. Oh, it's a series of dynamic queries, spatial organization based on fiber pathways. Okay, yeah, this is not uh, for the faint of heart, if you will. And this thing here, dynamic queries, star field displays, and a path spot fire. So this is actually, by the way, Home Finder right here. This image right here is the original dynamic query. This is another example that they were doing, both from Schneiderman's lab, talking about how dynamic queries work. That is what sort of started the ball rolling. And I would actually look at what the heck this is. Baltimore Learning Community. Continuous access, discrete grid. Yeah, I'll look into that one a bit more. Because it's some things seem terrible, but they're not. Some things are actually terrible. I thought we would have a lot more real, like absolute stinkers in this group, but people did not upload their information yet. That's what it's there. Teresa? Teresa. Okay, and one last one because I want to just see what people have. Then I'm going to turn off the edit access for a little while. So, can you walk me through this? What are we looking at here? Actually, I'll probably look at the original one. I thought people would have. I normally like things like see you learn are fantastic for these kinds of garbage queries because garbage queries like trying to find out how to turn off something in Visual Studio. But technically, like a dynamic, it's not a dynamic query. It's this big monolithic thing that you don't know how it's going to change when you type something in. So, uh, okay. So total budget. If I look at here, and the project. Yeah. Okay. Hey, this doesn't tell me a whole like it's changing. The query is changing. But wait, all projects should go down in size. Wait, GEF projects are larger than all. What? Yeah, this makes no sense. Okay, I like this. This is a nice stinker, right? These are all these projects. If you look at all projects, the bubbles can actually get smaller. They're not on the same scale, and it actually changes how you look at things. Oh, nice. Okay. Sebastian's so little one. Oh, that's pretty terrible. Okay. Oh, that's one of your favorite though. Okay, so maybe it's not a terrible, maybe it's awesome. It just has a weird background. I'm looking at Sebastian's, and here's Sebastian's dynamic query for Pokemon. It's a query builder. It's a dynamic query system. How do you dynamically query this thing? Oh my God, so much spam in here. I'm not going to be able to do that one. So what is, Sebastian, if you could also help me with this one, how does this thing work? Because am I able to selectively choose certain parts of certain?
Yeah, basically, it's a big, wait, can you hear me?
Yep.
Okay, yeah. It's basically just a big list of all the Pokemon that you want to make a team out of, and then the search box. There's like a crap ton of functionality. You can search by Pokemon's name. You can search by the tier that the Pokemon is in the competitive tier list. You can search by the Pokemon's type. You can search by any possible move, and it's just really easy to search up Pokemon and make a team really quickly based off any sort of parameters you want to put in. So it's like a super flexible dynamic system that accounts for like basically everything. So it's super nice for querying info.
That is surprising. I would not have guessed it would have been a super easy system given the big wall of Pokemon. But yeah, I mean, if it's doing its search functionality effectively, that's fantastic. One of the problems you're going to end up finding with something like this that comes up from time to time, like in your systems, is if I do a search and a filter and I don't see what the filtering criteria are later, I can add filters and filters and filters and filters and then not know how to remove them again later. If you want to see I think, trying to think here. I think, not rotten egg. What is it called? Oh, it is an online website for Newegg. There you go. There's an egg involved. Newegg for buying, computer parts, and their filters stay around, or at least they used to. So their filters stay around. So you add a filter and add a filter and add a filter, but then you don't easily see that you have these filters in there. And so effectively, you run out of items that you're visiting or seeing, or perhaps you add a couple filters and then you want to get rid of them. You have to find the filter again and remove it. Every once in a while, you'll see an example of one of those systems where when you add a filter, when you do a search and you add a filter, or you add a filter, not just a search, but a filter to your system and remove a lot of the information, and you add another filter on top of it, you quickly run out of items that you're viewing. And now you have to find a way to remove your old filters. And if you make that awkward, it's a clunky system as well. All right, nice. Let's just, I'll leave those open at least for now. I'm going to go over the center widgets thing in a second, but the big thing here is think about your interaction, how you're going about filtering. How easy is it to make a filter? How obvious is it to figure out what the filter does? Can it be dynamic? So when I add the filter, when I start adding the filter, do I start automatically seeing things? Typing in the Google search bar at the top, that was revolutionary. It was an impossible thing to do. Start typing in something and you get an autocomplete. But that helps me filter how I do things. Uh, if I have to write in the text and the text is wrong, so Honolulu, find trips to Honolulu. Good luck, right? And then you say Hawaii, and then you're like, how do I spell Hawaii? There's a whole bunch of words in or places, name almost any other country. If you don't speak the language of Hawaii, you speak the language, but for other countries where they speak a different language, knowing how to spell something breaks how you do a search. If I want to find a hotel in Cinque Terre and someone's only said it to me, how do I actually spell it? And if I spell it wrong, does it give me close enough results? Does it give me a hint of where I did something wrong? That's where dynamic queries come in. If I'm looking for Cinque Terre, or if I'm looking for Venice, I find a hotel in Venice, let's say. Maybe I don't want just a hotel in Venice. Maybe I want some of the local areas. A good query, a good filter might allow a little bit of flexibility in there, or maybe you want exact results, right? When I'm looking for a great example of a query would be when you're looking for airplane tickets, right? You say what date you want to fly on, And then it gives you a hint on the sides of what days or what times might be cheaper. So if you have a hard requirement, you can pay for that plane ticket. But if you have a soft requirement for when you can leave, you have a little bit of wiggle room. Look at the the airplane industry has some great querying for finding an airplane ticket because there's so much money to be made if you do it right. That's what we're that's what we're looking at here. Can I filter some things out in an elegant way? Because if I lose track of, if I look for sledding hills in Alta Vista, but there's a sledding hill just on the side next to Alta Vista, maybe I want to see that too. Maybe I don't. Maybe I want to find COVID things, vaccination clinics where they're doing, maybe I want to have a little bit of fuzziness. Maybe I want very strict, and you have to go through what your use cases are when it comes to that. Okay. Here's the other weird thing. So the scented widgets, like the airplane tickets, there are things called scented widgets. The idea is, and I'll go over the theory. I have an entire lecture on this. I'm trying to do the short version of this. If you think of foraging for information, looking for information, like going through the library and finding, information about a particular topic. If you were finding information for a research essay, there are ways you're actually sort of hunting for information. So the idea is, this is a known theory of, it's an established theory, but it's not, it's more of a conceptual framework than anything. If you think of looking for information the same way you would hunting, that's the idea, or looking for food. So you're foraging for food, foraging for information. You catch a scent, like, a wolf hunting something. You are following a scent to a destination for food. So you're looking for places that are going to give you the most bang for your buck. You do it naturally without even realizing it. So where do you go when if you don't know where to find something, where do you go? Well, a lot of you will go to Wikipedia directly. Some of you will just do a Google search to find something. If I don't know where something is or how to find something, so if I'm going to I'm trying to figure out how to lay, I had a term there. We just did the flooring in our basement recently. So when you have vinyl flooring that's supposed to look like wooden plank flooring, there's a certain term for it, but you also need certain equipment for it. What equipment do you need? Good luck, right? If I'm going to set up a Raspberry Pi to do a light show in my backyard, which is what one of my summer projects is going to be, good luck. How do I do it? What equipment do I need? I don't know. So how do I go about finding that information? Well, a scented widget is, I know certain places give me a lot of bang for my buck. So I go there first. I know sometimes when you buy one item, you buy another item together. That also that's a scent that helps me figure out where I want to go next. Scented widgets are widgets that give you hints about what stuff was around you. So here is a histogram, and I can see how recently people have visited certain ones or looked at certain things. That gives me a sense of where I might be able to find useful information. It's the most up-to-date information. Or maybe the most number of items are in data set C, or data set A and data set C. So I know which has a lot of information, more likely to give me a positive result. Or maybe this hotel has a high rating. So if I'm filtering hotels based on a whole bunch of criteria, but one of the scents I have is the rating of that place. It might be how frequent when you have people in what you're looking at for. If I could speak English, that would be great. If you're looking for a community festival or any kind of festival at a time, I'm blanking on the name of the fancy pants name of your group, guys. Sorry, but when you're looking at a festival in Ottawa, maybe you want user ratings, but maybe you don't. Maybe you just want the number of people that have visited that festival. You don't want to necessarily write that number down. What if you just encode it based on color? So the amount of saturation tells you how common it is for people to go to that festival, and the hue of the circle that you're using is the festival type. So an identity festival is this, a cultural festival is this, art and film festival is this. They're different colors, and the amount of saturation is how popular or how frequent, how common it is for people to go to that festival. If you want a festival that people don't go to the ones that are not saturated at all. Things like that. That's a scent. It allows me to try and navigate. If I have too much information, it allows me to try and navigate things. It didn't filter out attributes or anything. All it did was giving you a hint of where the most bang for your buck is. That's what a scented widget's for. Or I could do things like I have sort of nesting how many people are going to a particular place. And here's a legend, so I can see, I can also navigate or manipulate my legend itself. I love those things. So I have legend of what colors are, let me think of a good example. We'll see actually an example in a second, but what groups or what things I'm looking at. And so maybe I want this range between 6 and 25. So I select this subset of ranges, and that's what I see. I see the other stuff. I get my context, but this is the stuff I'm really looking at. Here would be the example. Hopefully it's going to work. Okay, so I can turn off certain things. I know that they're there, though. Notice that they're still around, but I filtered them out. So I have the context. I have what other attributes I can put in there. But at the same time, I can turn off LexCore because LexCore should be bigger than that. And Stark Industries really should be a lot bigger than that. Wayne Enterprises, MomCore. I don't even know where MomCore is from. I can filter out things based on the legend itself, but I'm still seeing it. I don't hide it, because if I hide that there, I can't get it back. It's a much more elegant solution than having a bunch of checkboxes on the side, plus the legend for the same information. So a lot of you want to have, I'm going to have a checkbox and a big slider and a big this and are there elegant solutions that allow you to seamlessly figure out what's missing, what's present here? Or maybe I have all this information and maybe some information about Aperture or LexCore on the legend itself. Help give me a sense of where the important information is or how impactful something is. I also like pointing out this, so hopefully this video is going to work properly. I'm also going to turn, the sound is not important. I'm going to walk you through it, and let's see if I can turn off I'm going to turn off my sound, hopefully. The important part about this, while we're talking about this is an academic publication. They're looking through all the different visualization research papers that have been published up until that particular point with different people. So they look for Catherine Plaisant and who she works with. She does a lot of work with Ben Schneiderman up here. That's where all these connections are. All our famous papers are there. We have the topics, the tags of the thing. Here are the papers themselves, and here are the people that she worked with. I love this original idea, but I want to point out something about the previous lectures while we're looking at this. So Peterson, is there. I like also skipping ahead a little bit. Databases, and we can look at case studies. But they worked on case studies together. Here's Chris North here. If we look at information visualization, we'll see people that are big in the field of information visualization, like Ben Schneiderman, Stuart Card, George Robertson. Who else is in there? All sorts of people. Mary Chwinsky is here. Jeff Gears over here. Pat++. So they're looking at all these sorts of famous research papers. Most cited research papers. I love pointing out, most recent citations, is it? Okay. Oh, it's only most recent in terms of information visualization. There is my supervisor way up here, in case you're wondering. I like pointing out the fact she's in a video. I'm not, but she is. You can see who each person has interacted with, what research papers they've published recently with. Here are the key terms that we're dealing with. Now, the point I wanted to bring up. Where the hell are you? What were your last queries? Where are you in this space? We're filtering really quickly, really easily. I clicked information visualization, everything shifts over. I click this other thing, everything shifts over. Where are you in the data space? I have filtering and aggregation. I have them very well done here, or at least filtering. I can filter and dynamically query this thing really quite quickly. I have no idea what I'm looking at right now or where everything is. I don't know how to go back to what I was doing before. I have no idea what the landscape looks like. This, unfortunately, the one thing I think it's missing is the overview plus context. I don't get a sense of the space that all of these things are involved or who's related to what. I don't get an overview because I filtered out and removed everything. So if I'm looking at John Statsko, I'm only looking at people associated with John Statsko, not where he fits into the entire space of publications in this field. And so you can say good things, great things and bad things about this particular research direction. I think it's really strange that you can get completely lost within about 3 clicks with this system because you can filter really efficiently, but I don't get a context. And I like pointing that out. All right. Let's see if we close that. And then, so here's what we've been talking about recently. We've talked about aggregating data, where I take the ways I can aggregate data. So I filter data, over this, remove it, either items or attributes. I can just rip them out. Aggregation is different. Aggregation is, instead of showing 5 things, I show 1. Either 5 attributes to 1 attribute or 5 items to 1 item. The classic example of this, just to put it into context for you guys, is something like your grades. I do an exam. People want to know what's the average of the exam. That is, remove all the items. You guys are the items, by the way, right? Remove all the items and give me one number, one magic number to represent the entire class on how everyone did on that one exam. If you are the items, it's aggregating all the items into one thing. Or I can do aggregate of attributes. Each exam is one attribute on your transcript, if you will, on how you're doing the course. I can take your average for your assignments and take the average of that. Or I could just sum them up in our case, right? But for the assignments in 2400 and 1400, they're averaged. That's an aggregate attribute in that case. So I can remove items and replace them with 1, or I can remove a whole bunch of attributes and replace them with 1. So we can do item aggregation. We can do attribute aggregation, which might also include dimensionality reduction. Dimensionality reduction is I have how similar is Tori Amos? Oh, you don't know who Tori Amos or Nine Inch Nails are, presumably. Name some cool act right nowadays and another cool act nowadays. How similar is Billie Eilish and I'm pronouncing her name right? And who name somebody else popular right now? Kids. Think of other, I'm trying to think of another person that I could throw in there. I honestly don't know any new music or any music that I'm listening to right now. Oh, well, yeah, Taylor Swift. Not related necessarily. Sort of not related. There are commonalities. How different are they from one another? How different is Drake and Kanye West? They have some similarities, not really that similar, but they have some similarities. They're both in hip hop. But that's about where it ends, right? There's some similarities in how do you group music? Can I take large number of attributes and boil it down to a similarity metric or some way of saying how similar two things are? That's where dimensionality reduction is. Can I merge these things together? Is hip hop a good enough explanation? No, it's not really. Right? Great music is great music, irrespective of the genre of music. And so can I what are the music that's most likely I'm going to like versus what you're going to like? Is there a way of visualizing that? Is there a way of boiling it down to a couple attributes? That's what a dimensionality reduction is. And then we also have a spatial aggregation. That's the third thing that we're going to be looking at. And that is take something like where you get to choose the boundaries of things and how do I merge them together. So here's item attributes. The classic is a histogram. If I want to know how everyone's doing, I bundle up all the A's and I say how many A's I have, how many B's I have, how many C's I have. In case you're wondering, for this course, I cannot give all A's, and they will look at the histogram to see what the distribution is. That doesn't mean I'm going to artificially produce, give people B's just for the sake of giving them a B, you guys a B or anything like that. It just means I have to grade at a certain level of difficulty, and I have to make assignments at a certain level of difficulty to sort of give that kind of distribution so that everyone doesn't just get an A. But if the assignment was, what is your name? Everyone gets an A. Well, one would hope, right? We need to make harder assignments to make that kind of distribution. So a histogram is a kind of distribution. It's how many people got each. It is the count of how many items or how many people had this particular attribute. How many people got an A? How many people got a B? How many people got a C on the exam? And it's that distribution. Okay. It's a very particular, it's not a bar graph. It's bucketing, if you will, bins of data. And it gives me an aggregation. Box whisker plot is the same sort of thing. I have box whisker plot is a bit different than what you've seen in other places. This is the median, not the mean, the median value. So what the midpoint of all of my data points is right here, 935 in this case. 1/4 of the elements are in this group here. 1/4 of the elements are in this group here. Another quarter are up here. Another quarter are up here. So by doing a box whisker plot, I can show how the items are distributed. You know, there's a quarter here, quarter here, quarter here, quarter here. Without showing every single item, I can just get this and I get an overview. I was making that suggestion with many people with stacked bar graphs, right? Where you can, instead of showing all the individual attributes, I could just sort of put all the attributes together, but you get the overview of how the total number that you have. But for each subcategory, they're also listed in there. So box whisker plot, great for distributions, sort of. Currently, I don't think you're going to have much say in the matter. I also know that I don't want to give all A's either, right? If you work really damn hard on a course, get an A, great. If you don't do squat, you shouldn't get an A the same way as a hardworking person does. It's, everybody gets an A is the equivalent of nobody gets an A, right? Because everybody gets there's no differentiation between anybody in the class. And how do you know who worked the hardest? How do you know what the standard of quality is if everybody gets an A? So that's at least my personal opinion on this one. But I'm not a big fan of everybody gets an A because it means that if I'm working really hard, there's no motivation for me to work really hard to try and get an A or work really hard to make some high quality piece of work. There's no differentiation. So it's the Olympics without any medals, right? Even then, or without a first, second, or third even. Okay. So here's the weird thing about a box whisker plot. Here is, I'm not sure if I already showed you this. I show this all the time, so I forget how many times I've shown this. Here is a data set. Here are all of my points. I'm moving them into these bands, into clumps. So this is a series of data points over time right here. Here's what the histogram of that series of data points looks over time. Here's what the box plot looks over time. You can hide a lot of stuff with a box plot. This data set completely changes. I get these tight bands of points in there, and the box plot doesn't show any of that. They're right there on the line for the interquartile range. The the second and third interquartile ranges, right here, right here. There's nothing in the center. Oh, there's a couple points in the center, but right? But all of that distribution gets hidden away with this. Aggregate data, almost by its definition, hides some information, or it increases complexity. Here's the same box plot with different distributions here and here. Here's what the raw data looks like in another case. Here's what the box plot looks like for each of those cases. So this looks like this looks like this looks like this. Hey, they're all exactly the same, despite the distributions being radically different in here. And here's what a violin plot looks like. In case you're wondering if there's other approaches, you might not, violin plots are hard to implement, but if you get one for free, fantastic, go for it. Violin plot gives you the same kind of information as a box plot. It tells you approximately where all the points are. The difference is it shows you the shape of the contour of the data set as well. So I get where the interquartile ranges are, they're not cleanly delimited like this thing is, discretized, if you will. Right? You don't have a clean line here, but you see approximately how the data is shaping. So if you have continuous data or like a distribution of data points, a violin plot is your friend. It's better than a box plot when it comes to showing distribution of data points, if you want to show that how the curve looks. So something to think about. It is how many points are in each of these areas. And so it gives you this approximate, it's an approximation, but it's a good approximation for what the data looks like. Better than a box plot. If you want, we normally do this as an in-class exercise, but I'm afraid of running a little low on time. So I'm going to just show you a couple of these things here. Series of different distributions. So here is what a box plot looks like. Okay. Here's a notched box plot. That's not so interesting. Here's a violin plot. It's unbounded, so it can keep going up here. So to the extreme ends, clamp to the data, clamp it down, fine. I love this. Here's a bean plot. Don't know why it's called that, but we have the little barring for where the data points are and how the distribution looks. Here is also, by the way, point. This is an estimation task. If I just put all the bands in there, put all the data points in there, I also get a sense of it, but I don't count the bands. I can have a B-swarm plot. I just put a circle for, every 5 data points, put a circle. And so I automatically get this curvature that I get here. Here's the scatter plot. This is what the data originally looks like, if you will. Notice it's different. This, I am not going to get a very clean view of what the data looks like. But if I aggregate it so that they all fit into little bands, like a B-swarm plot, it's a lot easier to get a sense of what's going on. We also go. And this is, if you wanted a trend line, right? It's trying to find, of these points, can we find a line to best fit? Trend line is another kind of way of sort of aggregating your data. It allows you to ignore all the fine details and get the general sense of the data. I love, this is actually one of the few times I think Mark Twain may have made the quote, but facts are stubborn things, but statistics are pliable, right? People attribute him to the term, there are 3 types of lies, damn lies, and statistics. He didn't actually say that. He re-quoted somebody else for saying that, or at least he re-quoted someone for saying that. But this is an original from him. Mark Twain is famous for saying little things like this, but, seeming to have a lot of contempt for statistics, because you can hide all sorts of sins with statistics. It's why I keep on, I'm sorry, but I keep on picking on the Green Monsters group for their statistics, right? Because I know what what it's trying to do, I know what they're displaying. I know what the conclusion is going to be. If you give raw data, you're going to look at it and go, oh my God, Ontario wastes so much power compared to Prince Edward Island. Oh my God, Ontario is horrible. It uses up, 200 times the amount of energy that Prince Edward Island does. Yeah, but they also, well, maybe not 200 times, but let's say 10 times more energy. Yeah, but they have 10 times the population. If you don't normalize your data for the population, you're conveying something that's not actually accurate. If you don't adjust for the number of the population size, we have things like vaccines, where my mother-in-law was complaining about the fact that Ontario got so many of the vaccines. They have so much of the population, but proportionately, they're the same number of vaccines. But if you just show raw data, everyone goes, oh my God, why does Ontario get more vaccines than everywhere else? Because we have the population for it. That makes sense. If you show the data the wrong way, or if you overly aggregate your data, you will throw things off and you'll get weird consequences from that. We're going to see an example. So here is spatial aggregation. The idea is I have a modifiable area, how I group things, how I bundle things up. You get the same problem with a histogram, right? If I choose a histogram the wrong way and the granularity is not right, what I end up getting is everybody gets a 79.5% on the exam, let's say, which technically is a B plus. Now, if I show the letter grades for all these distributions, I say, look how many B's I have in there, but everyone got a 79.5. If your total grade point average is based off of a percentage, I could give everyone a 79.5, look like I have a good grade distribution in my class, but really what I have is everyone's just on the line for A minus, so that your average doesn't get hurt, but yet it looks good to the higher ups at Carleton. You can lie all sorts of different ways with statistics. One of those ways you can lie about it is with spatial aggregation, where you get to choose where the mapping is. You choose the boundaries. And you might know where I'm coming from, or you might know where I'm going with this, because this is a huge problem both in Canada, but especially in the United States. So I want to see if I can share your sound, because it's going to come up in a second. So for spatial aggregation, I have modifiable area. I choose where I put the boundaries. It's a unit problem. How big the boundaries are and where I position them changes my data. And if I just give a raw number, it's going to be wrong. So if I just say Ontario versus PEI, population densities are wrong, right? Or I'm not differentiating between large city versus rural if I just do all of Ontario, for example. Different parts of where there are COVID outbreaks in Ottawa depends. If you go by ward, it's not going to actually tell you as much as area of town. If all the COVID outbreaks are in one area of town, but the wards are, you've artificially put a separation between those two wards, it looks like you have two wards that have an outbreak, but in fact, it's just one area. So the boundary definition could change how your analytics work. Gerrymandering is redrawing voting districts to affect the outcome of an election. And this is actually a known US problem, because the people in the local government for the state choose where their electoral boundaries are. They choose where they draw the lines for the Congress. So they choose how they draw the districts. Each district tells you is who controls the federal big part of who controls the federal government. Each state gets 2 senators, but a number of representatives in the House based on these boundaries where they draw the map. And the people that run the state draw the map. And if you have a two-party system, what you end up getting is, if you're a Republican, you make the map so it helps Republicans. If you're a Democrat, you make the map look like it helps Democrats. So this is, if I was supposed to have 60% blue, 40% red, what you would expect is, and I have 5 votes, you'd expect 3 votes for blue, 2 votes for red. That would be representative. Now, if I'm a Democrat, let's say here, I can carve up the districts so that I get 5 votes for Democrats. Not representative at all. And if I'm Republicans drawing the districts, I can make it so that you can't get all 5, but you can get 3 instead of 2. Still better for you. So you can carve up the district the right way, which is what the very idea of gerrymandering is. Okay, so we're gonna stop at 6 minutes, but hopefully this will give a good sense of what we're talking about. And I just like showing done over. So hopefully, can you guys, if you can't hear it, let me know. Also wondering, we also have this in Canada. The border for Labrador is also determined by the British choosing the direction of the rivers. That's why it's such a weird shape between the border between Newfoundland, Labrador, the Labrador part of Newfoundland, and Quebec. Yes, in case you're wanting to ever know about that sort of thing. So with this, I just want to, so we're talking about gerrymandering and why it looks like a salamander. This is actually, where is Manchester? So here's where the district is right there, and Boston's about right here. Yeah. Actually, no, Boston would be up there. Here is the Cape, for example. I love the fact that it all revolves around how crappy Boston politics is as well. So, but here are some of the examples of gerrymandering in action. We're going to stop very, very soon, but here are examples of gerrymandering action in North Carolina, like this thing. There's no way that this is by accident or this. This is one district that goes all the way around, down a highway, and all the way back over. And Cook County is left completely alone, right? Or here, notice San Antonio and Austin are 2 liberal areas, and so they have carved out, put all the liberals in one place. It's called packing a congressional district, so that all of their votes are in one area. You get that person, they'll vote Democrat in that one area, but all the other areas are Republican, versus losing 3 seats to the Republicans, you only lose 1. And it's illegal when it's done, if you can get caught for it, but it is fairly rampant across the US, and it's one of the major problems that they have. This is where we talk about, we're going to go to attribute aggregation, but let's see if I can briefly go over what we're going to be hitting soon. One of the things we can look at, I have an entire lecture on this, is multidimensional scaling and dimensionality reduction. So we have spatial aggregation, we have item aggregation, we have attribute aggregation. Attribute aggregation is how similar things are, or can I sum up something like your average in this class or your final grade in this class is essentially an aggregate of what you did in this class summed up into one number. That's what we're looking for. That ideally what you have is, it should be a representative sample of what you did in this class and how hard you worked. That's why we have these things. But there are ways you could do it so that maybe instead of a group project, the group project's weighted less and then the other one's weighted more. Or maybe you don't measure things in that way. But we need some way of sort of summarizing how you did in a class as a grade. And that's what we're talking about for dimensionality reduction. Can you provide a meaningful structure here? Can you take all of what you've done in university and sort of boil it down into a couple of attributes so that a future employer looks at it and goes, this person's good, this person's not good, or this person is going to be a good fit for our company, I should say, versus this person is not. Is this person top of their class or are they not? Is this person really passionate about this topic or not? Right? Maybe you have multiple different attributes, not just one number, but how do you break it down into this? So here would be examples of dimensionality reductions of attributes. The average and the spread would both be measures or ways of getting that. Most of your statistics are this. So when we come back next time, I want to do another in-class exercise. I want to finish off with this, but I'll give you a foreshadowing here. The House of Commons has a whole bunch of information about it, including every single thing that's ever said in the House of Commons. They're called the Hansard files. But you can figure out how people voted for things. You can figure out how many times they've answered questions during question period. You can figure out what how they voted, what they voted for, what they said during question period. You can say how often they agree with the prime minister. You could all sorts of different attributes. The question is, if we have all of this data, is there some way of aggregating all of these attributes per member of parliament so that you can quickly understand what your member of parliament is doing and how they compare to other people? That's what we're going to do as an in-class exercise next time around. Is there a way to get aggregate data for members of parliament and make a visualization on it? Because this is essentially what the House of, this is what the House of Commons looks like, where all the reds are liberals, all the blues here are conservatives, bloc, NDP, Green Party, independent, Speaker of the House. Knowing this and knowing how Canada looks, is there a way to do aggregate data on this? And I want you to play around with what kind of, like, doodle out some ideas for this. So that's what I might do now actually is you can actually do this on your own if you want to try it out. I'll also give some time at the beginning of class next time, but I would like to get some doodles, some designs for how you'd go about doing aggregate data for Canadian politics so that people can make an informed decision as politicians. And we'll look at this next time around. All right. Next up, I think I have office hours. I'm just going to grab a quick snack and I'll come back and I'll answer any questions you have. You can either email me, Discord me, or I can leave this on if you wanted to chat with me over Zoom. I'll just not record it. Okay. Thank you, everyone, and I will talk to you soon-ish.